Okay, good morning everyone. Let's start our lab seminar September 2, 2011. Today's theme is lab members progress report. So, today's schedule is every member have 30 minutes, but it doesn't include Q&A time. So no more than 40 minutes is good. But feel free to question. Let's begin this discussion. And first presenter is.
By the way, if you want the heated discussion, the chairman's work is very important. Controllers.
Okay. Okay. And the first presenter is our doctor student is, I think, better.
Why?
It's okay. And first presenter is presentation is we learn from first presenter, I think. So I want to present by doctor students. Okay. So, Mr. Gwen.
Okay.
Okay. Right.
I'm not the oldest guy in the But anyway, Mr. Chairman asked me to do the presentation. Pass button. Okay, good morning everyone. So today I'm going to talk about what I have done in this last month. First of all, I will recall the objectives for the period. What was the objective of my research in the last month? And after that, I will summarize the progress for the period. And the main work for the period is I have conducted several experiments on peer-to-peer wireless card, and I'm going to spend time to talk about this. After that, I will list some problems and solutions for my research. And finally, I'm going to talk about the plan for the next period. If you can recall the objectives for the period in my last progress report, that I must conduct several experiments on peer-to-peer wireless card and do some analysis on the data which collected from the experiments. I have two side works. That one is to establish a memorandum of understanding between CAPS of Tokyo Tech and Faculty of Information Technology of Lake Quito Technical University. We have opened a SOA summer school in this university in Vietnam, if you can recall. And I also applied for a member of organizing of IJOS, which is going to be held in Atami in October. Here's the summary of the progress. First, I have been accepted to be an organizing member of IJOS, so I'm going to Atami this October. And secondly, the MOU between the CAPS and the Faculty of Information Technology is almost done. So we need to make an application to the Tokyo Tech, and maybe it should be accepted. And then we send the MOU to Vietnam. And I'm going to talk about this. My main work is the peer-to-peer wireless card experiment. But first of all, because some of you are still not clear about what I'm going to use this peer-to-peer wireless card in my research, so I'm going to give my research overview, total imagination of my research. My research focus on study the intervention policies on the epidemic of avian influenza, swine influenza, and so on. So the two main research questions of my research is to study how much the efficiency of these policies, and is there any new policy feasible to control the epidemic of influenza. And the research that I have done in a master course focus on avian influenza in Vietnam and influenza in hospital. And I have done several conference work. The first two works is on avian influenza in Vietnam, which I collected the data of avian influenza in Vietnam, which have a huge outbreak in Vietnam and Indonesia in 2005. And the model for this research is developed from the famous SIR model into agents-based SIR model using unfolding methodology that I have developed by Professor Dixit. And in 2009, a worldwide outbreak of swine origin influenza. You can recall that it also affects Japan. And in swine influenza in 2009, it attacked schools and hospitals. So I changed my research direction to into influenza in hospital, and I have done this several works. So this is the theoretical studies that I have done in master course, and in doctor course, I want to develop those studies into practical studies, and I'm going to continue the research on influenza in hospital and study the infection control measures of nosocomial influenza infection. And we need to go to the field, go to some hospital to collect the data, and then reflect those results of field work into simulation, and then analyze the simulation results and give feedback to the hospital staff. So this is the main studies in my doctoral course. So before going to the field, I need, first thing first, data collection technique and skills. And also the data analytical skills is very important. And I also need knowledge and experiment, because once we go to the field work, failure is not allowed. So I need experience. And also communication skill is very important too. So first thing first, I need data collection techniques and skill. So I need to do a lot of experiment on this wireless card. So I'm going to talk about this. First of all, I'm going to give a small, brief introduction about this peer-to-peer wireless card. This pocket-sized wireless card can detect the nearby cards, detect the nearby cards via wireless signal, and record the ID and the distance and the contact time between these two ID cards. And it records in the both device, so it's called peer-to-peer wireless card. And this one, what is called?
Question. Distance means strength. Distance.
Distance I will show it later. It record the distance in signal intensity, contact between the two devices. Well, it uses AA battery and which lasts for 2 or 3 days, and the memory is said to be full in 1 day. And one card can detect from 10 to 30 cards at the same time. And it is a USB interface to connect to the computer. So I'm going to show how the interface look like. First of all, I connect it into a USB. And first of all, I need to know which COM port that this device is connected. So it's connected to the port COM. So here, one device is connected to port COM 3. This is how the USB interface looks like. Here we go. So now you know that there's only one device connected into the port COM 3. So I'm going to check one port here. And here we go. There's a card number 1, ID number 1 is connected to the computer. And I will show the configuration panel here. And let's see. There's several important value in this configuration panel. The first, this is the intensity, which from 0 to 100. If the two cards is very close to each other, the intensity is 100, and it ranges from 100 to 0. And this is the boundary, the above boundary is set for the card. For example, this is the 14. That means it's only record the card which have the intensity bigger than this value, And interval time is mean that the wireless card update the data in each 2 seconds. Very. So this already fixed in this version of wireless card, so we cannot change this. And the non-junction time, and this is a very important value. This is the signal power. That means this is set from 0 to 255, and this is the power of the signal that the device it emits to the. And here's the start time and end time of the simulation. So if you get change is to program and write the start and end time, then this card will go to work. And there's a lot of stuff, but we can forget. Well, for example, in this card, we can read the data, which is recorded into this card number 1. The horizontal axis is the time of the experiment, and the vertical axis show the number of which card that this card have contacted with, and is recording here. And in here we can see that is contacted with number 51, 52, 53, and so on. So this data can be saved into a CSV file here. Okay, so I'm going to show how the CSV file, what kind of data is recorded in this card. So here, this column shows the seconds, minutes, hour, and date. There's no month. You have to access to the card and to know which time that is recorded in this card. and the signal intensity, which is range from 0 to 100. So the bigger signal intensity, that means it is closed bit. And the card ID, so which card that this card have contacted with, and the more. So before, well, at the last progress report, I have told that I need to know the correlation between the signal intensity and the distance, because when we do the experiment, we know we want to place this wireless card in several rooms, and I need to know that which is the distance. Which is the best distance for this card to be placed. So first, before using this wireless card, I need to know the correlation between the signal intensity and the distance between the devices. So I have performed the first experiment. Here is the experiment settings. I selected a random sample of 6 cards. There are around 80 cards, so I collected a random sample of 6 cards, and I placed 4 cards into the card number 0, which I hold the position. That means I fix this card at this position, and I call these cards antenna. And these 2 cards is placed in the card number 1. This card is moving, can moving, so I call this cards the tag. That means it's tagged to a moving object. And then I move the card number 1 far away from card 0 in each 2 meters, and in each 30 seconds each. So this card is moving far away from card 0 from distance to 0 meter, 2 meter, 6 meter, and so on. And after I collect the data of these cards, I plot the data. In here, the horizontal axis is the distance between the tags and the antennas. And this is this vertical axis shows the signal intensity of those devices. So obviously we can see that well, the signal intensity decrease gradually when we increase the distance between the tags. And this is well, there's a significant variance between those cards, but this is show the average of performance of those cards, and we can see that the signal intensity decreased gradually when we increase distance between the wireless devices. And well, this device is we set the signal power is to the default value, and we can compare to this device which the signal power is set to 0. That means it's the minimum signal power that we can set. And with the signal power is very low, you can see that the signal intensity decreased very rapidly from the maximum value to around 30 in these 2 meters. So we can say that with this signal power 0, almostly we can only the wireless device only can coverage a space of 2 meters. We can have the radius of 2 meters.
So I have one question.
Yes.
In the why from 6 to 8 gradually increase?
Well, in this device, it will record the signal intensity between the two devices. And when we set it when we set it to 0 meters, which is very close to each other, it reaches the maximum. And when we're moving from far away from each other, it will the signal intensity, of course, will decrease. And that's very obvious, right?
Why from 6 to 8?
Well, this is the the performance of this card is not stable, and you can see that this card is, for example, the red one is the signal intensity decrease gradually, but this one there's a small up. So it depends on the card. So maybe there's a problem with the
But the number 35 doesn't have the 6 meters signal intensity. So I think the number 35 is also increased from 6 to 8.
Well, maybe this is the problem of the hardware. Maybe the hardware has some problem. I have done the experiment and because this is just a sample of the only 4 cards in 80 cards, so we cannot say anything about the total performance of the other cards. But this is a result of a sample of those cards.
Yeah, it's great. Please show me. When this is 66 meters, how about card number 35? Why is the data missing?
Well, I will have a look at it maybe because I have done this before, so I cannot recall why it's missing. Okay, I will check it later.
When Professor Deguchi designed this wireless ID cards, he didn't imagine about the distance. He only wants to know the signal intensity because which card this maybe the ID1 detects to. So you know that also the source there is no concept of distance.
Yes, that's right.
So maybe the distance is not so important. But the signal intensity is very important.
Yeah.
Maybe you understand.
Yes. So because I will show the experiment number 2 because as Dr. Ichikawa said that there's no distance term in SWAS. So we just want to know that, for example, we put an antenna in this room, and when you're carrying a tag, you enter in this room, this tag, they can recognize each other. That is fine. That is the goal when Professor Deguchi designed what is called. So maybe this is not so important when he designed this card. So in the experiment number 2, the objective is to learn how to convert those card data into SWAS animation data, and to do this experiment, I want to recapture the movement of a patient in a small clinic, and this is how the clinic. It is the layout of the clinic. There's a reception area and waiting area, and there's 2 small consulting room and 1 treatment room. And the patient will go from outside into the receptionist to do the reception for 1 minute, and go to waiting area to wait there for 2 minutes. and go to consulting room to be examined for 5 minutes, and go to treatment room for 5 minutes, and then go back to reception to pay the money, to receive the medicine for 2 minutes, and then go out. So totally 15 minutes. And to recapture the movement of patient number 1, I have placed 4 antennas that did coverage those areas in the clinic. And to set the number, the antenna number 51 to have a coverage of 3 meters, so to set it to coverage the radius of 3 meters, I have set it to the signal power to default value and refer to this graph. We want to know, it to cover 3 meters, so I set here the above signal intensity to 50. That means it only collects the card ID that which have the signal intensity bigger than 50. So the coverage area is smaller than 3 meters. So that's how I configure the wireless device. And I have done many experiments on this, and I converted with this CSV data that we have the time and the card ID into SWAS animation. So I'm going to show you how it works. Because the one step is only is 2 seconds, so I need to make it run fast. Here's the reception and waiting area, which is card number 51 is placed, and these 2 room, the card numbers 52 and 53, and the treatment room, card number 54. So, the patient come from the reception area to, actually he had come to this room, but because these 2 rooms is too close to each other, and the two cards is placed too close to each other, the card number, the card that the patient carry record the both card in this 2 rooms. So we cannot figure out when he is in this room or in this room. And because it's too close to each other, and it also affects each other, and we don't know which he's in. So, well, there's a big noise in the card data, because I will show you why that we cannot recapture the movement of the patient, because well, we can see a very big noise in the performance of the wireless card, the gap between those cards. This is only the sample of 6 cards among 80 cards. But we can see that there are gap in performance of the devices. So for example, I have said that we configure that the card can coverage only 3 meters, but in fact we don't know exactly the performance of the used card, the real performance. So I have done a lot of experiments on this using this layout to conduct a lot of experiments, but none of them successful. None of them was successful. So let's move to the next experiment. So I move to the next experiment that I want to capture the movement of patient in a bigger space, in a hospital. So in a larger space, and this time I want to implement the card data in SOAS visual cell, not an animator, because because the simulation model for my research is built in visual cell, and the movement of patients, of nurses, of doctors is one module. It's a part of the simulation model, and the simulation model is built in visual cell. So I need to know. I need to learn how to implement the card data into visual cell. So this is the scenario. The movement of a patient is the same. 3 minutes, 5 minutes, 5 minutes, and 1 minute. And now the space is larger, which I assume in a bigger hospital. And now, and I have convert the data. I implement the data into visual cell, and this is how it looks like. Well, implement the data in visual cell is harder work than animation. Now we have an agent card number 1, which is the patient. And there are 3 spots. The spot of card number 51, which is the waiting and reception and waiting area, the consulting room and the treatment room, and just run it. And I'm showing. One step is set 2 seconds. So in the first around 3 minutes, the patients doing reception and wait in the waiting area, and then in 3 minutes, the 3rd minute he moved into the consulting room for 5 minutes to be examined. And after 8 minutes, so he will move in 8 minutes. Yeah. And he will stay here for 5 minutes to be treated, and then go back to receptionist in the next so 30 minutes. Okay. So this is. So in this experiment, we have successfully recaptured the movement of the patient in this scenario. Okay, there are some problems which appear from the experiment. The first is, I have said before that there's a big variance in performance of wireless card. So the solution is to set the signal strength to default value and allocate the task with a appropriate distance. That means, for example, in one room like this, we should only place one antenna. I'm sorry, these antennas. We should place only one antenna in one room like this. So we can recapture the movement of the people. So this is the suggested solution, and because we need to collect data of movement of doctor, nurse, patient in a quite big hospital. So I need to use a lot of cards, maybe all those cards. So after collecting the data, I have to deal with a huge data of maybe more than 50 wireless cards. One card, one CSV file, and a lot of data. So I need experiments. I need experiments before I go to the field work. So I would like to conduct the next experiment in SOA Summer School that I will ask students to carry the wireless card during summer school, and I would like to recapture their movements during the summer school when they go to the cafeteria, when they go to the convenience store, or when they go outside or in the conference room. So I'm going to consult with Professor Deguchi and Dr. Ichikawa about the possibility of doing this experiment. And of course, I will need your support, so please support me. Thank you very much. And well, the plan. Yes,
please. Please. The first paragraph means a calculation, a kind of calculation.
First one.
Yes.
The solution.
So absorb the individual distance, difference of card.
Yeah.
This is called so-called. This is called calibration.
Calibration. Yeah.
Yes.
Yes. That's right. Thank you. All right. So the plan for the next month, I have several works here. Maybe a very busy September. The first is to the wireless card experiment in SOA Summer School, and then I want to build a simple model, like that model that can recapture the movement of all students in SOA Summer School in business now. And well, I have to finish the application to Tokyo Tech, and then I have Professor Deguchi to sign the MOU and send the MOU back to Vietnam. And well, of course, we have a big event in September, the SOA Summer School. And also, well, in the end of this month, we have SOA Summer Seminar. So very busy September for all of us, right? Okay. Thank you very much for your attention, and please follow my research reports on my homepage and first class personal board, and every advice and comments are welcome. Thank you very much.
Senor, a question.
Yes.
I read data about maybe same purpose.
Yeah.
They have maybe same purpose, and they use PHS to collect data moving.
Who?
国土交通省。
Oh. Yeah. Yes. Well, this kind of device, this not the first device to do some kind of work, but the concept of this device is very suitable for SOAS because well, the data, the log data in this card is very similar to animation data, and this is our original one because it's developed by Professor Deguchi, and we have that kind, a lot of 80 devices. So I know that is not the best one because there's another very small, a smaller part that Nitala have. Then they have this wireless card to collect the movement or the contact of the people But well, the problem that we should use what we have and use its
The
best.
point is that card in Niterab is not Niterab card. That's
yeah.
from Toshiba or Hitachi, that it costs too much.
Yes, and you know that Professor Dixie spent a lot of money to develop his original card. So we should use what we have and use its best. So, well, maybe your research, you can use this kind of card. You have the problem of research some kind in the same way. So if you want to use this card and you want to know how to use this card, feel free to ask. Of course, it's not the best card in the earth compared to other. Compared to other cards, it's very big, and well, I use this and I find a lot of problems. But anyway, we must use what we have and use its best. It's all we can do. Yes. Actually, last year, Mr.
It's maybe 2009 or that we tested the virus card in our lab. Maybe organizer is Mr. Komatsu. And there are maybe 20 people, and we receive some schedule sheet and moves exactly as the schedule. And this is a student room. Reality is changed now. But in this room, there are about 5 or 6 devices in here. And Komatsu tested which virus card is equal to which one. And he cut it by the strength level.
Yes.
All students have the virus card right here.
And then he make an animation.
Yeah.
Anyway, convert the data into the animation is an easy task because the data is quite similar to animation data. But to collect, to implement it to Visual Cell is a hard work because the system is very different.
But the data may be very noisy. So,
Yeah.
so the calibration is most important using such a sensor device.
Yes. You know that we have a hidden cameras in our lab, so be careful. What you've done in the students' room is recorded.
In this test, we moved every 5 minutes.
But there was big noise, right?
So he cut it.
Yeah. Okay, another question?
Did you use the log explicator to make animation file
No, I just converted directly.
using the Excel
yeah.
writer?
No, I didn't use the explicator, but I hacked this animation file because the animation file is a zip file.
Yeah, I know that. Yeah, the log explicator has the function to convert the virus card log data to animation data.
Oh, I didn't know that.
So yeah, you maybe had the Komatsu's first class.
I have such in his first class, but
I think that Mr. Shirakata made that kind of function in log
yeah,
explicator.
maybe, yeah. Mr. Shirakata is still in.
Shirakata is not in High-Tech now.
Oh, yeah, that's right. I have searched all the first class, but I can find only the animation file,
Yeah.
the animation file, but no source or no program or no anything script to convert the card data into animation file. So I just hacked the animation file, changed the ANM, right, animation file into zip, and you unlock and you unzip, decompress the file, and you can see you can change the log file, and then convert it back to animation file, and read it by animation, and it works. That's not a good
You made a zip file.
zip file.
I mean that you made, that as you said that
Yeah.
animation file is a zip file.
Yeah.
So you convert the log file to a kind of the file, then you compress as a zip file, then you
Yes.
Animator has a function to import the CSV file as the animation file. Maybe you can find a button or a menu, maybe import from clipboard or that kind of thing. So just copy the Excel file, then import it into the animator, then you can get the animation.
Anyway, because convert to the animation file is not the final objective, because we need to convert it into visual shell, because the model is in visual shell. Animation is it's good for showing demonstration.
The comment is that I think that it is not so important to convert the log file to visual shell file. Maybe you should analyze the log data and make us a kind of rules of definition, movement definition rule. Maybe that that, for example, some patient who has a sick, maybe you can get the log. Then you can think, okay, sick patient moves like that, maybe 80% to the room 1 or so. You should make that kind of rules. Then import, maybe you change to the rules as a log.
Yeah, I have think about that, because we need the final goal is to know, because know the patterns, the moving patterns of patients and doctor and nurse. Because, for example, you collect for 1 month, and 1 month you collect every 2 seconds, every single movement of in 2 seconds of the whole, of all the members. Then it's a huge data, and maybe SWOT doesn't work with that huge data. So maybe from the card data, we need to do analytical work on that data to find out in which probability this kind in this place, and which possible probability this kind in this place. So maybe Dr. Ishikawa says.
Please make a pattern maker.
Pattern maker.
We need a pattern maker.
Yes. Pattern maker maybe.
Yes, maybe we can construct get the data only for 1 month and look the pattern and what is the important pattern from the activities of the members and hospital, and then you use only this data. Maybe this is important.
And export as a role is important.
Yes. So maybe the role will be simpler, and the data is simpler. So because the whole model, for example, the model I have built in master thesis, very big, it's very complicated, and it costs a lot of memory to run it. And with huge data to be implemented into the model, maybe the model cannot work with our system. Yeah, that's right. All the rough data we need to maybe process the rough data to find out the patterns and make the rule based on the patterns. Yeah, that's right. Yes. Yeah. Other comments?
show me the 19th. Not the advice. The workshop. There is no summer school. SOAS workshop. The first SOAS workshop. We changed the name.
This changed you changed name.
Yeah, no longer summer school.
Oh really?
Yeah, workshop.
Why we change the name?
You know that in the conference we call SOAS tutoring. That maybe 2 or 3 hours tutoring, and maybe that SOAS project is almost 10 years, so we can organize a symposium, like have a survey presentation about the research using the SOAS, or we can organize a tutorial.
Okay.
So in that case, maybe we can organize like a summer school, but summer school is only in summer.
Yes.
Now some anymore.
Yeah, right. So, okay, workshop is very fun. The 3 days workshop.
Yeah,
The
so
tutorial
we
is
can
a couple of hours, and the simple is a total one. So, okay, so I changed that.
Okay. So
And-
we can make the regular
Yeah.
event.
And okay. The important thing is that the summer school is an activity as done by university or laboratory. It's very hard to get money from participants.
Yeah.
Workshop.
We can.
Yeah. Okay, 3 days,
Yes.
1,000 yen.
Okay. Yes. Okay.
And so you said that you want to do the experiment.
Yes.
Maybe you should prepare some check sheet
Yes.
with where you.
And I need to know because maybe we need to need cooperation of Seikyo. We want to put 1 or 2 antennas in that area and convenience stores. And yeah, I will prepare.
And I think that there's not so many people attend the workshop, so you can ask the participants to join this test.
Thank you very much.
So, yeah. 受付に置いて、これ首にかけてください。
That's nice. Any other suggestions?
日本語なんだ
はい。
多分やっぱりもっと詳細なキャリブレーションが必要だと思います。やっぱりハードウェアの個体差が大きいんで、なんだろう、多分送信の強度と受信の感度を両方測定してそれをちゃんとジャスティファイという流す差をなくしてノイズをなるべくとにかく減らさないと詳細な実験は行き詰まるんで。
そうですね。実験1で何回もいじって10回ぐらいですね。いろいろななんだっけ受信強度と受信のパワーをいろんな値をやったんですよ。でもうまくいけなかったんですね。このレイアウトでちゃんと測って距離測ってレイアウトを作って10回ぐらいやったんですけども、必ずこの53番はねすごい強くていつも53番に引っ張られちゃうような。
だからそれを要するに修正するためにキャリブレーションでちゃんと強いもの電波強度の強いものはちゃんと弱めてで、感度のその後多分受信感度の違いが出るのでそれも吸収して
多分それをやるために多分全部のカードのパフォーマンスを知らないといけないですね。
要するに結局キャリブレーションってそういうことなんです。カードに付随するその性格を全部吸収するためにその測定データを集める。
この実験1話だけは10回ぐらいやりましたけど、全然ダメでした。
逆にそれぐらいの要するに高精度細かいやつはキャリブレーションやらないとデータ取れないで最初、まあ、前もあったんですけどベッドが並んでる時にどのベッドにいるのかというのを識別する
やりたいんですよね。
精度がいるんでそれは絶対キャリブレーションが必要な
例えばこう距離の近いやつっていうかそのカブレーションが必要なやつだけは10個を用意しといて10個だけをこうしっかり把握しといて
まあそうですね全部や要するに高精度の、実験用例えばやっぱりちょっとタチの悪いやつとかいると思うんでやっぱりそういうのはちょっと選別して比較的いいやつ
それ80個を全部整理するの結構これは必要ですよね。結構ハードワーク。
いっぱいいるじゃん。いっぱいいるじゃん。働いてくれる。
まあそれは数なんです。
皆さん修士の方々カードの使い方を分かるといろいろ例えばね自分の研究でもなんか授業の課題とか
太田君が使うから。
使うの？
だって取るんでしょ行動パターン。
いやそれはでもなんかアンケートとかでね。
いやこんなんあるんだからさ。
あと多分最初の方でグラフで6メートルがへこんでるって、あれ多分なんか干渉島からが出てるんじゃないかな。全部のカードで全部落ちてるってやっぱり何かありますよね。
設計でしょ。
まあだから
結構ランダムに選んだんです
けどね。ってことは要するに向きは同じなんですよ。
向きは同じです。
だから多分干渉島の同じパターンが出てる。
このハードウェアには全然わからない。
ダメだからそれは要するに一点にだからそういう干渉島でへこむところがない部分だけを取るとか
逆に2メートル以上はですね、逆にどうでもいいんですよ。どうでもいいっていうか、その場にいればっていうのが要は高精度じゃないので、2メートル以下要は例えばこのベッドの次のベッド大体2メートルとか1メートルが1.5メートルなんですけども。このベッドにいる例えばこの看護婦さんがこのベッドにこの患者さんを治療するかそれとも隣のベッドかそれが要は 2メートル以下のそのカルクレーションですかね。
でこれはキャリブレーションで干渉島ですって言うんじゃダメなんですか？
いやだからそれあくまでも仮説でしかないし
証明できないでしょ。電波がどういうのを出してるかと波長で合わせれば干渉島になってるかどうかは分かるでしょ6メーター。
あとこう自分のモデルのバウンダリーセッティング例えば一つの、部屋は一つの場でいいっていうだったら、いいんですよね。
まあそこら辺が工学的態度との違い要するにやっぱボトムのちゃんとトップの要するにどう使うかというアプリケーションの方を進めると同時にやっぱりボトムのセンサーの要するにノイズを抑えるとかそこら辺のやるのと両方進めないとうまく噛み合わない。
とりあえずあるものを使ってこれまたレイク先生はお金をかけてもっと正確な
ハードウェアとしては多分見分けあっちはよそで持ってるかもしれないけども目的が違う可能性がある。それ多分10波かなんかで非常に長い波長の、電磁波を使っててよそは多分もっと高周波にデータ載せたりするんでそうすると高周波って解説しないんで障害物に弱いんですよ。
これ結構強いんですよね。
これは中波だからもうほとんど、ほとんど大丈夫なんです。
どこにいたかしか取る目的でないからね。
要するに定量的な測定には向いてないんだけども、
近づいて結局最後にはパターンを取りたい。
いやパターンを取るのはそれのレベルであってて看護婦さんがその中でどう行動したかっていうのを取りたいんでそれは別の次元で取らないと全部一緒に取ろうなんて絶対無理だからこれはこれでよくてそのチェアに1個ずつ仕掛けたのは別パターンで取らないとそれをエージェントのベースの中に組み込むのは全然構わないから別の次元で測ってあげないと全部一度では多分無理だと思う。
まあ結局一個一個置いてどれが一番強いっていうのを取れればいいんだけども今個体差でそれが埋まっちゃうレベルですよね。だからその個体差を取れば 取れるはずなんですよ。要するに正確な距離なんていらないんですよ。今それができないレベルなんで、それを乗り越える必要があるんじゃないかなと。
ありがとうございます。
And the other question.
You show me the fifth slide.
Which type?
5枚目。
はい。Maybe in your next presentation, show us the goal of your doctor research. And expected contribution to the social world. Maybe make this kind of system, and you should ask hospital to use this one to manage. Maybe that one is the goal, I think.
And I will think by, well, I will report in the next conversation. So how many minutes have I spent? Well,
You use just 67 minutes.
well, the Q&A is not included.
Yeah, I know.
And I forgot. Okay.
Yeah, but I'm very happy to receive a lot of comments.
So the presentation is good. Maybe there's a mini discussion.
Okay. Thank you for presentation. And I forgot saying I leave this child once at 15 minutes and twice at 25 minutes. And I think it is difficult to finish all presentation. So, short every presentation or to 日本語で失礼していいですか。今日全員分終わらせるのちょっと難しいと思うんで、1人分のプレゼンテーションを短くするか、プレゼンする人数を削るかした方がいいと思うんですけど、終わりますか？大体今1時間ぐらいかかったんですけど、あと
短い人もいる。
短いっていうか、もらった資料の感じだと期末に上がるのが3人ぐらい。
そしたら終わんない方がいいですか？
来週やってね終わる。
もう普通にそのままやってって終わんなかった人は
M1 は1時間もかかんねえだろこれ。
終わんなかった人は次って感じで
終わると思うよ多分。
終わる。分かりました。
だって1人1時間で行ったって
3分ぐらいで終わる。
10時間でしょ。
8時
1人1時間で10時間でしょ。
いや、
9時に終わるよ。
そういう一応5時ってなってたんで5時まで終わんなきゃいけないのかなと思ったんですけど
終わるじゃん。
分かりました。このまま続行してもうちょっと
時間5時になってから考えたら。
はい。じゃあ1人何分とかは気にせずに予定通り Q&A は気にせずにします。So the next presenter is okay.
research. What I have done through my research is there are three. The first one is because in the last seminar I have some input from Nguyen-san about my model, and I think this input is very important. So my model is changed because of no logical explanation about the aspiration, how I use this formulation. So I changed, I revised my model, and the second one, because I construct the source. Before I write by MATLAB, and after that I convert the source for my model. And the third, this is what I was have done, what I saw with Ishikawa Sensei about 4 months ago about how to export the output data from source to Excel file. Because in source, in our simulation, we need not only one running, we need maybe 10 or 20 or 1,000 running for our simulation to the loop iteration. How many running, how many iteration. So this is difficult because in Solas we have a log file and we put the one running for the same parameter input, and then running, and there are log file for each output we want to expand, and then running again and run again and run again. So in this I construct, we only simulate the source only one, and there are output file in the Excel file. We in the first running, second running, until how many running we set, and then it is the column cell, and the row cell is for how many iteration, and then we can in the one workbook we can make sheet, how many sheet we want to produce. In each sheet, what is the number variable we want to export the file. So this is make our work more easy. So we only simulate the source one times, and we can collect all the data from how many running and how many iteration in one workbook, and have several sheets, how many sheets we want to generate. Because in the before we use this, maybe we only copy the log file to the Excel file and made some change to the appropriate data we want to see. So this is what I have done in this summer. Before doing the first, I revised the model. The model is about the adaptive system, about how to balance the exploration and exploitation in learning organization. So this is based on the March model. What I want to do is how to improve the knowledge level on side of organization. in the previous model, Marx model, the average of knowledge on side of organization is not optimal. We can say it is not optimal. So how we can maximize the knowledge on side of organization? This is some kind of mutual learning. Both sides, members of organization and organization learn together. So this is how we can see how exploration of new idea, new method, new technique can be balanced with exploitation. Exploitation means we use or we improve the existing method or technique. But in the exploration we search. But in the exploration we have risk. Because if we change our technology or our method, maybe the result may be not so high if we use the old technology. But maybe with exploration we found the higher technology. So our organization can be improved with exploration. But to do exploration, members in organization have risk because they maybe fail. Maybe organization give some fault to the members to explore, but maybe fail. But if we use the existing technology, we also already know how about the output of the old organization. But maybe this is only not optimal, only suboptimal. So how we can improve the optimality of organization? We need exploration. But how we can balance between exploration and exploitation? This is important. So this is the background. If the system more exploration to adaptive system, suffer the cost of experimentation because we need experimentation without gaining many benefits. This is the risk. If we more exploration, if more exploitation, need to maintain that in suboptimal stable equilibrium. So we need to not more exploration and not more exploitation. So we must balance and maintain appropriate between exploration and exploitation. This is the important thing. So this is the organization learning. Both sides learn together. So the knowledge of organization can be the routine as rules, procedure, convention, strategy, and technology. And this routine is based on the experience of the members. So the member can improve the routine, and also the member can learn from the routine, and also the organization can learn from experience. This is the mutual learning between members in organization and organization itself. So this is the routine can be improved by the members, and the other members can learn to the routine or to the technology. This is some kind of knowledge management. So this is the Marx model. This is the agent-based model. So we have external reality. We coding by -1 or 1 randomly in the m dimension. In m dimension. So the members in individual in the organization or the member make some belief about the reality. The belief is maybe -1, 0, or 1. 0 means he know nothing about reality. But if this one in the first dimension is same in the reality, he correct about the reality. So how many dimension correctly by the external? This is means by knowledge. How many, how individual can perceive the reality based on the position of dimension or reality and belief of individuals. And also, organization have a code. Code is also -1, 0, or 1. Same like this. So the knowledge or how we can count the knowledge of organization, how many correctly position and the dimension have same number. So if we have 5 dimension of reality, -1, 1, -1, 1. This is the reality. And if the individual has this, they only correct 3 because this is correct. Yes, this is correct. This is the correct number. Yes. So this is wrong. This is wrong. So this is there have maybe only three correctly how he perceive the individual. So the learning is individual can learn from organization code by socialization. So there are parameters of socialization. If with probability of socialization, the code of individual belief can change. So if this is the individual belief and this is the organization belief, so if this is wrong, not same, so this is can change to -1. This is the process. So in the position in belief of individual for each dimension, they can learn from organization code. And also the organization can learn from the individual based on performance base. So we select the individual who has higher knowledge, who has correctly perceived the individual, and we select it this, and he can change. The members can change the code of individual. This is the simple. I think it is the simple model because they the model present the knowledge only like this, only coding on based on -1, 1, -1, -1. This is a very simple model. This is I have socialization process. Members can learn. So if there are probability of socialization, so this is can change because this is not safe. Yes, this is externality, and this is then can improve like this. So this is the change of socialization. And also organization code adaptation process. We select the members of organization who has the higher knowledge, and based on this member, this is the permanency I have already talking about. This is the organization code. So we selected individual who has the higher knowledge, and then this is the members of organization for each dimension like this. Yes, this is the how many. This is the reality. This is the reality. How many members in the selected group to have the same? This is same 1, 2, 3. Yes. So this is the how many he make a correct. And there are 2 members not correct. So there are difference between who has a same like reality in the one dimension and who has the wrong perceive about the reality. So based on this, we have probability of change or probability learned by code. So in March model, they have 2 probability: probability of socialization and probability of learned by code. So based on this probability, if this how many differences between how many people correct the reality and how many he wrong the reality. So if this is positive, the code change to 1. If 0, neutral value, and if the number of -1 is more than the number of 1, it changes to -1. So this is based on how much member perceive the reality very well. So if the number of 1 is more, then the reality become the code become 1. But if the number -1 is more in the selected group, the code will change to -1. But if the same, the number of 1 equal to the number of -1, they do nothing and make the code back to 0. This is the simple how to understand this. So there are 2 systems, open and closed system in the March model, in the environment of organization. Open system means this is the open system. The reality is not changed all the time. So if we generate like this code, this reality not changed. I mean the entity of each dimension is not changed. And also the individual, like in organization, no newcomers, turnover. This is turnover effect. There are no newcomers. They are on go out from the members of organization. They are no. But in the closed system, the reality change, and there are turnover. There are newcomer comes to the organization with the new belief. So if we have organization, if we have all have already worked in this organization by 5 years, and if I go to go out to the organization and replaced by the new one, and the new one have a new belief about how the organization run. Yes, because they are newcomers from the organization. So the newcomers can change the belief of the other individual, the all members, and the newcomers will change the all member, or all member can change the newcomer.
Excuse me. Could you explain the open, the meaning open and meaning of closed?
Close mean we not interact with the system is not interact with the environment. So in this model, no effect of external reality. So in the closed model, external reality is not changed. So, but in the real world, the reality is changed every day. Yes, but in the closed system, the reality is not changed in this model. and there are no individual turnover. But in the reality, organization have newcomer, and there are members go out to the organization. But in the closed system, these two turnover and the external no change in external reality is the closed system. But in the open system, we change the reality, and also we have turnover. We have newcomer come to the organization.
Okay. You explained that open system is not in open system. You explained external reality is not changed.
It's changed. Reality is changed.
It's changed.
Open
Okay.
system. Yes.
Yes. You said that in open you said external reality is not changed.
Oh no. Sorry.
So I asked you why open, why?
Sorry.
Okay, we understood.
Yes. Yeah. I'm sorry.
So in open system, newcomers will
Yes,
come.
they come. Yes. Newcomer. In the open system, newcomer comes and they are changed in reality.
Okay.
But in open system, there are no change in reality, and also there are no newcomer comes to organization. I'm sorry. Okay. This effect of change in reality and turnover can make the learning process is very difficult. So this is turnover, and in the model it means environmental turbulence. So every time, every iteration, the reality change with the probability P4 and turnover. Every iteration, newcomer comes and replace, and new one of member of organization replaced by newcomer, and this is the turnover with the probability P3. So this is P3. There are parameter probability P3 turnover. There are change of environmental for each dimension. Maybe in this reality can change -1 to 1. So this is can change -1 to 1 with probability before.
Okay.
Yes.
In this system, there's no local minimum come from external reality. I think the evaluation may be very smooth.
Yes. There are no
Local max, local optimal.
local because but maybe in closed system maybe the optimal knowledge can be found, but in the open system maybe we can arrive at local minimum only. So what I said, the open system is very difficult, and we maybe tap in the local minimum. So this is the parameter P3 and this is P4. This is turnover. Its period individual has a probability P3 of leaving the organization and being replaced by a new individual with a set of new beliefs. Turbulence, the value of any given dimension of reality shift from -1 to 1 or 1 to -1 in a given time period with probability before. So this is the replication. Maybe this is better to understand the model by replicate the model itself. So I replicate the model so we can understand how about the model. So this is the result. The optimum equilibrium knowledge can be achieved by slow learning on side of code and fast and on individual and fast learning on individual. So if the probability learned by code is higher, then we can see this is the optimal. With the socialization process is slow. So slow learning inside or on side of the members is better, but organization must learn fast. So we can see if the individual learns slowly to the code of organization, the individual have diversity because they are not convergent to the code itself. But the code must learn rapidly to the selected individual. We can find, but this is not the optimal. The optimal, all members have a perfect perceive the reality is 1. But this is not only about 0.95. Only 95%. The members can perceive the reality. But in turnover in the closed system, only about 75%. So this is the turnover is very difficult. This is the replication. So this is I got from the March model. There are no diversity inside of members. So I propose the law of variety, so the members can make experimentation. There are 3 experimentation procedures. There are 3 based on this model. There are 3 unconstrained experimentation, organizational constraint experimentation, and rational set experimentation. This uncontrolled. All members cannot be controlled. They can experience every time. So this is maybe difficult. And the second is organizationally constrained. The individual, the organization made the control about the how members can make experimentation. But this also top-down approach. Maybe there are no bottom-up approach. But in the last rational self-restrained experimentation, this is based on rational. If I, the member of organization, do I make the experimentation? I ask myself, why I made the experimentation? How about the risk? So this is based on, but how we can make this? So based on rational self-constraint, I use aspiration based on aspiration level. So I can improve my knowledge if my goal is not achieved. Yes, because I want to improve my technique or my learning, because my aspiration or my goal is not achieved. So I improve. So this is experimentation, aspiration. But if only individual made they improving about their goal to achieve about their learning to achieve the goal, maybe every individual can make different aspiration. So there must be interact with other to improve their aspiration level. So they can share the aspiration level. So all members have same aspiration level in the end of organization. If the organization stable, so if the organization stable in the running, all members can have same aspiration level. So what I changed in the model is, this is my previous research. I built this. I only put this based on how probability to experimentation. This is the learning process based on aspiration level. So if there are a propensity of experimentation, So if the individual make experimentation, they can make the payoff of performance. Based on the performance and aspiration, they are stimulus. The difference between aspiration and performance or payoff. And then they are cumulative stimulus. We use response function and update the propensity of experimentation or probability of experimentation. This is my previous model. And then we change probability of socialization with this condition. And I only change socialization probability and not change the P2. And I will analyze what effect of probability by the code based on socialization process. This is experimentation process. This is the technical process for my model. This is the updating probability, and also this is socialization process. If aspiration of individual I at the any time with lower than organization, so they can change the value. This is same, learned by code is same like the Marsh model. And this is the interaction process to share the aspiration level. This is same like my previous explanation. This is updating organization. And this is the result from the closed system. We can compare in Marsh model and purpose model. And we vary the PD2 probability of learning by code. We can see the purpose model in the closed system can achieve the highest equilibrium knowledge. But with the learning probability learning by code more than 0.6. But the overall result purpose model is better than the Marsh model in varying P2 parameter, probability parameter. So the experimentation or exploration process by the individual creates and perceives requires variety of knowledge necessary for the organization. But this is the closed system dynamic of aspiration. We can see this is the knowledge approach to correctly perceive the reality, and this is the individual and organization aspiration. We can see they tends to not make the big differences and tends to zero the difference between organization and individual aspiration. So they have same aspiration in the end. So this is important. Organization, all members in organization make the same aspiration and also same with the organization aspiration. This is the important. But in case of open system, this turbulence effect, this is 0.02. This is extreme result. So the average knowledge is drastically decreased. But if the moderate turbulence 0.01, the purpose model is better than the Marsh model in the open system. So this is my conclusion. The importance of balancing exploration and exploitation can improve the knowledge of organization by control restrict experimentation by individual. This is the important. So this is the second. We must balance also aspiration between individual and organization. There are no big difference between members' aspiration level and organization aspiration level. And the third one is experimentation make the risk, but if we can control our experimentation by learning, the risk can be reduced. So this is my conclusion, but I want to explain briefly about how to make the Java export file. But this is not in the. But maybe yesterday I discussed with Tanuma Sensei how to make the import the Java file, and I have already done. And this is the Java class file. I use GXL AP. We can download freely from this from the Java source net. You can GXL jar. We can download this, and this is I create only several functions. The simple version of Excel. There are operation of number, but this is not include. I only include how to make the file, this one, string file, and the second, how to generate one workbook, this one, and how to open worksheet. How many worksheet we want to open, this one, and how to get the sheet. So maybe we can open the sheet, but if we want to fill the sheet, we must get the sheet before we fill the sheet. So the sheet refers to sheet number, what number of the sheet. So we can see in the Excel we can see the sheet is 1. Yes, how many sheets we can? This is the 0, the initial, and this is the first 1, 2, and 3. How many sheets we can generate? So if we click sheet 0, we can see the table and the sheet like in the Excel. And this create font, this is for this create font Times New Roman or how size of the font is, and this is add number. There are only two. This is the simple one, integer and the double and real number. And also this is the important, write and close. After we write some data to the Excel, we must close in the end of our simulation. It is the key end of the exporting. So because in the Java to the Excel, they save the exporting data temporarily before he write and close after he from the temporary repository. This is the process. So we must use this, write and close.
It's try pass me.
Yes. Yes. This is try. I only use the simple one. So this is try. We can change this. This is the source stage. In the init stage, we only make one workbook and how many sheet and create the name of sheet. In this model, I use two names: probability of cooperation for player 1 and probability cooperation for player 2, and create the sheet. This is the loop counting. How we can generate how many iterations in the inner loop, and the outer is running. So this is the simple one, like this, the looping. Set value, we set how many run. If the running is lower than how many run we need, and iteration is lower, we must make the condition like this. So what I use for the looping is this is next stage. Next stage is produced like while looping in ordinary programming language. So next stage. So for each iteration we have next stage. After that, this is the last procedure. So if in the last procedure we call iter plus 1. So if the iter plus 1 is already exceeded y, we set iteration to the initial value. This is the looping process. So we can see this is the BM model, Bose-Mosteller model. Prisoner dilemma. So in this I use the keyword. This is the file name to the output. This is the path, and this is the seed name 1 probability and seed name 2 probability to players. Probability compression for player 1 and player 2. And I use running iteration is 100 and running 4. Oh, only 5 running. So we can running this. Okay, and we can see in the file documents they are tried Excel. This one. This seed is probability for player 1. This side is probability for player 2. This for the first running. This is the iteration until 100. Until 100. The first, second, third, fourth, and 5. This is not 5. 1, 2, 3, 5. This is for the player 1, and this is for player 2. We can also create the string, the title of this. What is this? We can. So we begin with the second row. This is can be used to export our data from source to Excel directly with only a single experimentation. So based on this, we can make some Excel analysis in this Excel file. Okay, thank you. I'm sorry for my long explanation. If there are any questions. Okay.
Me again.
Okay.
Let's show your proposed model.
Yes.
The next slide. Yeah.
Yes. This one.
Can you show me the equation for probability P1 and P2?
Probability for P1.
P1 and P2.
Probability for P1 we change to this condition.
All right. So.
This condition. This is the dynamic aspiration rifle from both sides individual side and also organization side.
So it should be
So if individual target is lower than organization target, they can change their belief about the organization. So the enforcement from individual side is based on their organization. So if my goal is lower than the organization goal, I want to improve my my work or my knowledge.
So that means the aspiration is the, motivation to learn.
Yes.
So naturally, the guys with a big aspiration should learn more.
Yes.
So he have
Motivation.
the motivation, right?
Yes.
So he have the big aspiration level. He have the motivation. Then he should learn from the organizations. Do you think so?
I think if
Logically.
people have a higher aspiration level, maybe they has a big motivation to improve their learning. But in this case, like aspiration used to experimentation, this is some kind of control mechanism. So if only one person or several members in organization have the big aspiration level and he make more learning, but the other is not, this is not also can be stabilized for the organization. So in this condition, the aspiration of individual learning by individual can only be done with this condition if the aspiration is lower than organization aspiration level. So if he want to improve the learning from the code, this is learning from the code. So if the code made the more power than the side of individual, so individual want to learn. But if not, if I have more knowledge rather than the organization knowledge, I not learn from the organization. This is means.
I think logically, people with high motivation will have a higher possibility to learn, because the goal is to increase our motivation, right?
Yes, but
So
in this
this control will stop the the learning.
learning by the code, no learning from the other. But if we want to learn to the organization, if organization not better than my knowledge,
This is not the knowledge, but this is aspiration, right?
this is only the condition to learn from organization. So if this condition satisfied, then individual learn to the code.
Yeah, I know that, but
Yes.
the logic,
Uh-huh.
the logical. Do you think that a problem? Because people with high motivation, so people with high motivation will have a higher learning rate. That's the logic, right?
Motivation, but
And
this is aspiration. So I explain the aspiration like the goal. If we have the set our goal is X, so we want to achieve the X. But if we already receive the X, we satisfied and we not improve. This is the concept of satisficing. On the you can read the paper of I forgot This is the satisfaction concept. If one have already achieved the goal, he satisfies. But if he not achieve the goal, this satisfaction is, so he improve. So in the side of people satisfied, they not motivate to learn again in this formulation. But if the people is dissatisfied, the target is not not be achieved, he can improve the process of learning. Is me. So this is based on the theory of Marx and in 1955. This is the old paper. This is the base paper of people satisfaction.
So, in your model, proposed model, the goal is aspiration level,
Aspiration.
right?
Yes.
But in match model, the goal is the knowledge. The P1 in match model.
Yes, this is probability.
Yeah, probability, and the goal is to improve the
Knowledge
final
level.
knowledge.
Knowledge level. Yes.
So in your model, the goal is the motivation for the people to learn.
Yes. Based on aspiration.
Based on aspiration.
So,
right? So the
but
goal is the
in
development.
aspiration level is improved or changed by the performance, by knowledge. So how the knowledge he can receive. So this is the formulation. Aspiration depends on the knowledge. So the how people can change the aspiration, it depends on how much knowledge he get. So they are related correspondence between aspiration and.
Yeah, I just want you to be careful because your model and match model, the control of learning is different.
Yes.
The
yes.
control of learning match model is based on performance. To get a better performance, they learn,
Yes.
and so on. The total average of organization knowledge increase. But in your model, the goal is to increase the aspiration level. But you compare in the results your model and match model in average of organization knowledge.
Yes.
So you
we
have to
get-
be careful with the the logic.
Maybe this is the main. This is the match model without this. So the source of diversity only from the individual beliefs learned by the code. But the individual cannot make experimentation. But when I read the paper about the three kind of experimentation, these three kind of experimentation, I choose the third, rational self-restraint experimentation. But how the people can control their motivation to experiment? This is the problem. There are no research dealing with this, the third. Unconstrained experimentation, no control. Organizational or constrained experimentation is top-down approach. The organization, you can make experimentation. Oh, you don't. This is the top-down approach. But the rational self, this is top-down, bottom-up approach. But how to control? If we not to control, we arrive in unconstrained experimentation. So how to control this? So the control is people learn by people make the control by aspiration. This is the concept. So this is only make the difference between my model and the match model only in the design. Only design. I change the probability P1 to this condition and retain the P.
The
P2 is retained, like
the equation for P2.
the
Equation for P2.
probability to not change is 1 minus lambda. Okay.
Okay.
This is based on the Mars model. Mars model also use this one. The P. Probability to change. The
What is K? And what
K is the number of correctly perceive the reality from
and
the scientific.
lambda.
And lambda is in the dimension, the first dimension, how many the individual weight the quantity. Then the K is the difference between correct, perceived, and minus
So
different.
it is not the proportion of individuals.
No. Yeah, this is the last.
Okay,
Yeah, you
so you
have
should-
explained. Yes. Okay, thank you very much.
Yeah.
Yeah, the previous I will use the proportion, but like Mia-san say, there are no explanation about the logic for explanation. There are no logical explanation about the proportion. Yes, thank you very much.
And the last one.
Yes.
The total organized belief is you analyze the organization knowledge with with change in P1 and P2.
Only P2.
Only P2.
Only P2.
Only P2. Only P2. So only P2. That means you don't include the effect of interaction with. That means only P2. That means only organizations with and people and
Yes.
individuals.
Yes.
But how about the interaction between the individuals affect the results?
I'm not yet to I only set the probability to interact is randomly 0.5. This is random. So maybe if the interaction is frequent or not, I'm not. Maybe related to my previous research, I use the neighborhood, some kind of a grid. This is maybe can be next.
Yeah, because that is the reason why you use agents-based model.
Yes,
Because
yes.
the interaction between the agents, how it affects
Yes.
the total organizational
Okay.
knowledge.
Okay.
So that is the reason why you use ABM.
So maybe in the local interaction and the general interaction.
Maybe something like interaction rate or something.
Yes.
How it affects
The result. Yes. Thank you very much.
Yes. Okay, that's all.
Okay, thank you very much.
Any other question?
Not the question, but the request for the next your progress with presentation. Maybe you should make some maybe summary of your domain, because I mean that you change. You know that Gray-san's theme is similar to us, so we can easily understand his. But for me, I think it's a little bit hard for us to understand your domain. So, and your model is changing from the master's research to the doctor research. So you should summarize your research domain again
Okay.
as a background of your doctor research. Then maybe, and I want know the similar model of your domain again. I think you already explained the similar research or previous research in your master thesis, but I want to know the difference between your doctor purpose and the previous one. So maybe make 4 or 5 slides to compare your research and the previous research, and also your main topic.
In the doctor.
Yeah.
Yes.
Then show us, I mean, explain us your original model, like today.
Okay. This is the.
Yeah, and maybe in your explanation of your model, maybe you should compare with other models. This is maybe, for example, this point is my advantage compared with other previous model. You know that there is not so many references.
Yes.
In Dr. says the reference is very important. What's your contribution is main topic?
Yes. Maybe what I want to do this because in the previous I used the model for the game.
Yeah, I know.
For the comparison game.
Yeah.
But how I can extend in the real application, like in the organization learning. I have a question. What my model work in the other model? So maybe if they are only work in the game, maybe it's not cannot be used in all domain. But when I use this to the other model, I found that the model can improve the situation in than the previous. So I compare the March model and my model, and they improve. But they improving only in the closed system. But in the open system, the turbulence effect is very, in the extreme case, the model is same, March model and this model. But in the moderate level of turbulence, this is the March model and the March model. There are big differences between. But if the turbulence is lower, this is because the turbulence, the changing of environment is very, very difficult to handle, because the environment changes, the aspiration also changes. So the aspiration cannot convert to the certain value. This is the difficulty, because after the changing of external code, people do experience every time people do experience. But in the closed, the reality is not changed. So if the code from reality is the same from the belief of reality, so he cannot improve anything. So this is convergent state. But if the reality changes over time, so there are no convergent. But we can achieve, like Tanuma Sensei said, the suboptimal result, not the optimal, but suboptimal of the result in the open systems.
I think there's no little merit of organization in the closed system.
Yes.
It has only harmful inertia.
Yes, maybe maybe in the reality we can find the open system is the more case in the reality. So in the next, if I want to continue, I must make how to handle the variety of the changing of the external reality. So maybe I have already talked, this model cannot be improved based on aspiration, because if aspiration is, if the external reality changes, aspiration also changes. Aspiration level cannot convert to the certain value. So the aspiration level to the if we use the aspiration level to handle this experimentation process, maybe there are some mechanism we must add edit to this model to make the signal to the individual when he can experience or make experimentation or not. This is so important. So maybe I will improve according to the reality. The closed system is not exist in the reality. The open system is turbulence and also turnover. This is the reality in the in the organizational learning. So maybe there are some paper they are related to knowledge management. The knowledge management program. They also use this simulation model, March model, but improve the March model. But because I must read the paper. But in the knowledge management, there are some steps how people can inform their knowledge to the organization. How there are mechanism of reward and punishment. They are in the knowledge management. There are also the mechanism, some mechanism like this. So maybe in this, if they are fail to make good experimentation, they have to punish. So if they can make good experimentation, they can be rewarded. This is some kind of mechanism we can add in this model. In the reality, there are mechanisms like this. People who have made some funding, new funding in technology or in the method area, they can be the reward. And people who not make the improvement, they can be punished. This happen in the side of reality. So how we can make imitation about this reality to the model. This is maybe I will think in the next research.
Any other question? Okay.
Me again. I'm sorry. And because in your model, the individuals and organization improve the knowledge by experimentation that controlled by dynamic exploration level, right? So I think that you need a literature review on this, because this is the backbone of your model, right?
They have to.
Yeah, you have to persuade the
Okay.
listener that this is true.
Yes.
Yeah. And I think you have read some paper, right,
Yes.
about this, so you can list out that reference. Yeah, and do a review on previous research based on this, dynamic aspiration.
Dynamic expression.
You have to persuade that this is true,
Yes.
because this changes everything.
Okay, thank you very much.
And not for your research, maybe advice. You said that you made a function to convert, convert SOAS original file to the Excel file. You know that Microsoft, maybe they will change their API or maybe the Excel system. Maybe your function no longer can be used. So maybe the comma-based data format or tab-based format is important.
Yes.
That's the original Excel file. So would you change to the not directly XLS file, but maybe CSV file or TX, only the text file?
Before we change to the Excel file.
Yeah, before. Not direct to the Excel. You know that.
Maybe we can use the file from TXT file from the save of source. Source can provide the TXT file. The log file from source. TXT, CX, what is the
CSV.
Yes, the log file to save the log file from the source.
It's just only the tab-based text file.
Yes, text files.
Yeah.
Maybe we can use this text file first to convert to the Excel.
Yeah.
Maybe this. It's not directly.
Directly, yeah, because you know that some people don't have the Excel file, Excel software. So you know, in Mac there is a number software names number like Excel software.
Okay. So maybe.
So that the universal format is important.
So maybe we can use the text file.
Yeah,
This
and
is-
then base.
this is one
yeah,
of the-
yeah,
yes,
and tab base or comma base is important.
So the user can use this raw data to
Other
convert
software like a Mathematica or and you know that SPSS or the,
Okay.
and also Excel can open the tab-based text format or comma-based text format. So it's not so important to convert the
upload
original
directly
Excel
to
file.
Okay.
Yeah.
Okay, thank you very much.
I have talked to you yesterday about this. You know, SOAS can run for one at a time and explore to file,
Yes.
and the file is in the log file.
Yes, log file.
And we have one from 1 to 100 folder.
Yes.
And last year when I do my research in master course, I have run for 40 times, and I have 40 folders, and it says separate log file in separate 40 folders, and I just write some VB code, Visual Basic code in Excel, and it read from all the file in each folder, and consolidate, take the average, and sum and variance and so on. So I think you can.
How about making a new log analyzer? Log analyzer, you as you said that if you run several times, there are several folders and several log files. So just select the folder, the top folder, then the log analyzer searches the all results, and in there is a tree menu. The test 1, test 2, test 3, test 4, and in the test 1 there is some text file, and the user can say, okay, merge all log files or average all files. Right?
So maybe in Visual Basic is easier to handle that.
Maybe the Visual Basic only video.
So.
So using the Java is fine.
Yeah. Maybe this is only my intended is only to see.
Maybe all of us need that.
Yeah. So that maybe Manahan can use the Java, so he will make that kind of.
Maybe this
We can all use that.
Yeah.
export file from output file from source. I think I only use the source. So I not maybe in the next I will take the original source of source to modify directly to the original source of source. But this is not the original. I only use the visual cell. So I want to look. I want to see it is work or not. So we can make the repetition or the looping from the original. Maybe if I allow to make the modification in the original source, I can change the Java and make the looping in this original. So we can set or make the interface, some interface like how many run, how many iteration, how many and set. And so the next time I will ask Ishikawa Sensei or Tanuma Sensei to allow me to find the original source, and I want to modify first modify and to discuss how the interface we can build if we want to embed it this to the source. So we not use the looping so maybe this is difficult to make the looping in the soil. Use the next stage. Maybe we can find running no finish because the condition or there are some stage we use not appropriate to the choose to the next stage. So the looping is not end the looping. But if we can convert this looping to the original source of source, maybe people users only can click how many running, how many, and pick run and save to file. Okay, so this can be running, and the so we only the data only one folder, and one folder consists of the iteration and how many variable output we want. One experiment, we choose one folder, and in the folder there are aspiration 1, aspiration 2, aspiration, and if we click the aspiration 1, there are some running and iteration. So people found like this file, like Chikawa Sensei say, so people can convert the file to Excel or the appropriate with the user interface. If the interface has Excel, it can run in Excel. And mathematics, it can import to it can export to mathematics or to MATLAB or that. So this is my previous my next work.
Today I was just attended an official meeting of our faculty, and today in the afternoon I also have to attend another meeting. So today I can attend a little of my presentation. By the way, so you know, this is Oshin Tsukutsuku Semi.
Oh.
今日はそこの木のところにたくさん泣いてた。かわいそうに。これから逃がした。みんなに成果を見せてから、その辺にセミたくさんいるから。あれは小さいんですね。これをつくつぼのして小さいね、羽がある。それのメスですね、これは。泣いてないやつ。皆さん虫取りしたことがない人はここは虫取りの方法ですから。
泣いてるやつと泣いてないやつ知らない人いる。
私の妻は持ってません。
そこにいますよ、持てないの。
いる。可愛いよ。誰か触ってみたい人いますか。いない。最近の方は理科の先生もこれ虫取りできないっていうのが多いっていうんでね、ショックでね、今それで食って捕まえる。イメージした。
クヌギのところにカブトムシを。
というわけですみません。今日人事の会議がどうしようもなかったので、この後またちょっと2時からまたちょっと会議に入りますので、プリーズ勝手に今日はちょっとだけ。
Maybe let's design some functional software together
Okay.
to improve the software.
Okay. Maybe when I do this, I have learned many things about the solar side and about the Java side. So maybe
How about the Spring?
yes, I have already learned this. So maybe one I want to improve the source is to make the plotting. The plotting is to make the interval size and also the color and also the legend. So maybe we can add this. So the figure can inform much for the user, for the reader. So maybe in the source now the color is generated randomly. So this depends on what variable we set. This is so when I did this, I have encouraged to make improving about the source. This is my first step to improve the source, and he worked, and so I want to this is make me feel satisfied to make this experiment. This is the simple experiment, but this is can encourage me to improve. Okay, thank you.
Okay.
Thank you.
Yeah, another question. Okay. Thank you for.
Okay, thank you very much. I'm sorry, maybe it's too long.
We don't mind that.
Maybe just you have finished your presentation about that is strongly connected to AAS.
Yes,
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 okay,
yes.
okay. Have you received my mail
Yes.
from Finland? A small comment.
Yes, I have already.
Okay.
Already.
It was
Yes.
too strong.
But I also already convert the program to.
Yeah. So
Already.
we have another chance to discuss about our total.
Okay.
Okay.
It's the deadline is yesterday, but
But deadline was
extended.
extended. You know?
No.
Oh, okay, please check your website.
Oh, the size was. Oh, okay.
Then maybe you can send a revised version also,
Okay.
if it is
Maybe
required.
we can arrange when we can discuss.
Okay.
Okay. Thank
Yeah.
you very much.
Okay.
Okay. Thank you.
Anyway, so I have just come back from Finland, Aalto University. I attended and I gave the lecture about our service system science at that university. And at the same time, I attended doctoral course discussion at Aalto University. So, well, doctoral students training style is a bit different from between United States and European domain, and also Japan. And especially in European domain, they stress on framework making. So at the start point of doctoral thesis, they have to construct their methodology and framework. So of course it is a very, very nervous one, not so good one. But anyway, so to show your methodology and framework is a very, very important training, especially in European domain. And I also love that kind of approach. So of course, every time I always say framework. But anyway, so not the intermediate examination or last examination, but to the first point of your doctoral thesis, maybe especially doctoral candidate, you and you, where is where he is? Okay, Google. Okay. That candidate, it is important to show your methodological framework. So, except your content, okay? Before content, that is a actually abstract way of thinking, importance of course, in master students, it includes our intensive training. So, as a first step of doctoral thesis, actually, I recommend you to construct your methodology. So, formally in this faculty, so in doctoral student, doctoral courses, intermediate examination and last examination we have. But in our laboratory, I'd like to especially focusing on methodological framework of doctoral thesis. I'd like to inspire by Aalto University style. So now I'd like to say, you doctoral candidate, you, and also you. So I hope maybe we can arrange a special time for your methodological framework discussion. So I hope maybe Natsuzemi no around the end of this September. so we'd like to have a chance to discuss. So I hope anyway, so you haven't constructed your total scheme or total research program. But anyway, so please prepare your standpoint or your framework you want to do. Okay. So we'd like to have a discussion for doctoral candidate. Okay. Thank you. ということで、じゃあもうこれで午前中おしまい。
一応そのつもりだったんですけど、昼休み、結城先生少ししか入れないんだったら、
2時にちょっとあなたたちでちょっと別の打ち合わせがどうしても入っちゃう。
先生来ないですよ。
今日来ないの
7時まで来ないですよ。
あ、今日7時あれ今日夜の7時だっけ
さっきメールが来て、
あ
抜けられないから7時まで
でも7時に来る
しょうがないん
え
2時から5時まで向こうの予算会議
分かった7時には来る
7時に来るかを7時程度しか書いてないので、台風が来てます。
台風来てんの
東側なので雨が嫌です。
軽いですね。
全然来ないじゃん。わかりました。じゃあちょっと、そういうわけで午後参加できます。はい、問題ない。
じゃあ昼休み大体何時ぐらい？掃除は今日やらないですか？
じゃあやってよ。
やりますか。終わった後です。
すぎだよ。
でも終わった後でしたね。
1ヶ月やってないんだよ。16階のトイレみたいなことになる。
じゃあ何時ぐらいまで？1時半ですか？1時半だと長いです。
1時間くらいでいいんじゃない？
じゃあ1時半。